All right, so we're getting into linear equations, and one of the most important part of linear equations is the slope of the line. So something that kind of crosses over is that unit rates, something that we've been working on, are just different types of slopes. And slopes are used when we actually put our data into a graph. So the unit rate and the slope are essentially the same thing, but a unit rate is a standalone piece of data, while the slope is a huge part of our graph that represents the data. So, in any rate, the unit rate represents this thing we call the change of y over the change of x, meaning that the y value, meaning the value going up and down, is changing, and the value going left to right is changing. And unit rates represent that. So, but in these pictures 1 through 6, all we need to identify is the change between A and B, meaning how did I get from point A to point B? And we do that just by simply counting the units on our graph. So first we always, and when we deal with slope, we always want to deal with the change in y, meaning how far did it go up or how far did it go down? Well, from point A to point B, it looks like it goes up 1, 2, 3, 4 spaces. So I'm going to write a positive 4. And you're probably, why do I need to write plus 4? We know it's positive. I just like writing the plus sign just to represent, again, I'm going up 4 as opposed to down 4. All right, then from that spot, how far do I need to go to get to B? Well, I count 1, 2, 3 spaces to get to B. And for the x, the change in x going to the right is positive, going to the left is negative. So I want a positive 3 change. So rather than writing the positive, since they're both positive over positive, I know the slope is a positive 4 over 3. And again, you could have known that by looking at the line on number 1, because the graph has a positive slope going from left to right. You can see that it's going upwards, and it's a positive slope. All right, number 2, looking at the line here, let's go ahead and take a look at what kind of slope we think this is. From A to B, again, from left to right, it's going down. So this is actually going to be a negative slope, and we'll see if that's true with the numbers that we find. So the first thing we want to find is the change in y. So we actually have to go down this time, 1, 2, 3, 4, 5, 6. We have to go down 6 spaces, so I'm going to write negative 6 for the change of y. And then from that spot where I stopped, to get over to B, I need to count 1, 2, 3 spaces, and I went a positive direction. So negative 6 over positive 3 actually reduces to 2 over 1, but it's just going to be a negative 2. Very important there that we keep the sign, so it's going to be negative 2. And as we confirmed, we already know it's a negative slope because of the picture that we interpreted before. So my slope here is negative 2. All right, moving on, let's look at number 3. Again, we want to find the change in y first. So from A to B, it goes down 1, 2, 3 spaces. So I'm going to write negative 3. And then to B, it takes 1, 2, 3, 4, 5 spaces, and we go in the positive direction. So negative 3 over positive 5 will result in a negative 3 over 5. And again, we know that because looking at the line from left to right, it actually goes downwards. All right, and 4 and 5 are very similar, but I want to take a look at number 6 here. Look at number 6. Notice how A and B are on the same straight line. But we can still use the same methods that we've been talking about here, the change in y over the change of x. So, from A to B, does it go up? No, it doesn't. It's on the same line. So it doesn't go up, and it doesn't go down either. So is there any change in y? There's no change in y, so we're actually going to write 0. Okay. Now the change of x. Well, from A to B, I have to go over 1, 2, 3, 4, 5, and I went to the positive direction, so it's positive 5. So 0 over 5 is my slope, but let's think about it. If I have nothing over 5, again, I still have nothing, so my slope is actually 0 in this case. So when it's a straight horizontal line, it's called a 0 slope. So we still use the same principles, though, as if we were counting with a regular slope. So this is how you find the slope of a line. When you're given the graph, you just count the change in y over the change of x and reduce if possible.